In this question, we want to determine the measure of the acute angle to the nearest tenth of a degree between the two lines shown. The complicating thing about this question is that one of the lines is in vector equation form and one of the lines is in Cartesian equation form. Well, from the vector equation form, we get the direction vector to be 1, -8. It's right there. From the line in Cartesian equation form, we see that the normal is given by the coordinates a, b. In other words, the normal vector is 3, 4. Well, using our knowledge of normal vectors, we know that a direction vector would, analogous to a negative reciprocal slope, a direction vector is going to have the order of the components changed with the sign of one of them changed. So in this case, the direction vector of the second line is 4, -3. 3, 4 becomes 4, 3, and then change the sign of one of them, 4, -3. And now we can get the angle between the two direction vectors, because we have two lines in R2 that aren't parallel. They therefore intersect at one point. So to determine the angle at that point, we simply have to dot the two vectors, the two direction vectors, and realize that the dot product in component form, which is given by 1 times 4 plus -8 times -3, is also equal to the magnitude of the first direction vector times the magnitude of the second direction vector times the cosine of the angle in between them. So in other words, 28 is equal to root 65 root 25 cos theta. Dividing through, we see that 28 divided by root 65 root 25 is approximately 0.6946, so that theta is the cosine inverse of that number. Well, using our calculators, we see that the cos inverse of 0.6946 is approximately 46.0 degrees. So the measure of the acute angle between the two lines given is approximately 46.0 degrees.